So a piggy bank contains 6 coins, a dollar, a half dollar, quarter, dime, nickel, and a penny. If you were to randomly take 3 coins out, how many different sets of coins could you get?
Okay, so this is what we're wondering to know is sets of coins. We're wanting to know how many combinations can we make with that, those different opportunities. So I was just pulling up a formula for combinations just to show you guys. So permutation would be the same idea, but that would be if the order mattered. So we won't use permutations. We'll use this combinations formula here to help us find the number of combinations that we can make with all of this. So in the formula, and we actually talked about this exclamation point last week or a few weeks ago, it's called a factorial, and I'll explain that in just a minute. But n is going to represent the set size, so the total number of items in my sample. So my set size in this case is 6 because there are 6 different options of things that we could pull out of that bag. The R in this equation is going to represent the subset size, meaning the number that we're selecting. In this case, we're picking only just 3 different things out of the bag, so our subset is going to be 3. So we're going to say our R is 3. And if you know these 2 things, you can actually find out how many different combinations we can make with it. So we're going to say C is going to be equal to n factorial, which is 6 factorial, and then over R factorial, which is 3 factorial, and then times n minus R factorial. So we'll say 6 minus 3 factorial. And I'm just going to kind of walk through the steps of simplifying this. What I want to explain is that 6 factorial, or this factorial, just what that means is we're going to be multiplying by the numbers, the consecutive numbers counting down all the way to 1. So 6 factorial is the same as that. So I'm actually going to I'm going to expand that on the top there to show you why this simplifies the way that it does. So we'll say on top we have that on our numerator. On the bottom we have 3 factorial, so we'll say 3 times 2 times 1. And that's going to be times, I'm going to highlight this here. Over here is times, so 6 minus 3 is 3 again, so it's another 3 factorial. So again, I'm going to say times 3 times 2 times 1. Now there's a reason I expanded this rather than actually multiplying these out, is because I can simplify now before multiplying and not have to do a lot of multiplication of large numbers. So I'm going to get rid of 3 over 3 because that just equals 1. 2 over 2, that just equals 1. 1 over 1 just equals 1. And so what we end up having when we simplify is on the top we have 6 times 5 times 4, and on the bottom 3 times 2 times 1. And we can just actually go ahead and multiply those out. So 6 times 5 times 4, we get 30 times 4, we give you 120, over 3 times 2 times 1, over 6. And then 120 divided by 6 is going to give us 20. So after all that work, we found that we have 20 different combinations that can be made from this set of items. But the combination formula, it's really nice to know because it helps in all different types of situations. As long as you know your whole set and your subset, you can find out the number of combinations.